Today we shall study about the line spectra of hydrogen atom in the atom chapter. According to the third postulate of Bohr's model, when an atom makes a transition from the higher energy state with quantum number n1 to the lower energy state with quantum number nf, ni to nf, nf smaller than ni, the difference of energy is carried away by a photon of frequency BIF, nu IF, such that h nu IF बराबर E n I minus E n F. इसलिए h nu IF बराबर me4 बटा 8 एप्सिलॉन नॉट स्क्वायर h स्क्वायर 1/nf स्क्वायर माइनस 1/ni स्क्वायर और nu IF बराबर me4 बटा 8 एप्सिलॉन 0 स्क्वायर h क्यूब into 1/nf square minus 1/ni square. Equation second is a radioic formula for the spectrum of the hydrogen atom. In this relation, if we take nf barabar 2 and ni barabar 3, 4, 5, it reduces to a form similar to equation. For Balmer series, the radioic constant is readily identified to be R barabar me4 bata 8 epsilon naught h q c. 8 epsilon naught square h q e. If we R बराबर me4 बटा 8 epsilon naught square h square c. If we insert the values of various constants, we get R 1.03 10 to the power 7 per meter. This is a value very close to the value 1.097 10 to the power 7 per meter, obtained from the empirical Balmer formula. This agreement between the theoretical and experimental values of the radioic constant provided a direct and striking confirmation of the Bohr's model, since both nf and ni are integers. This immediately shows that in transition between different atomic levels, light is radiated in various discrete frequencies. For hydrogen spectrum, the Balmer formula corresponds to nf barabar 2, ni barabar 3, 4, 5, etc. The results of this Bohr model suggested the presence of the other series spectra for hydrogen atom, those corresponding to transition resulting from nf barabar 1, ni barabar 2, 3, etc., nf barabar 3 and ni barabar 4, 5, etc., and so on. Such series were identified in the course of the spectroscopic investigations and are known as the Lyman, Balmer, Fasen, Brackett and Piffin series. The electronic transition corresponding to these series are shown in figure 1. The various lines in the atomic spectra are produced when electrons jump from higher energy state to a lower energy state and photons are emitted. These spectral lines are called emission lines, but when an atom absorbs a photon that has precisely the same energy needed by the electron in a lower energy state to make transition to a higher energy state, the process is called absorption. Thus, if photons with a continuous range of frequencies pass through a rarefied gas and then are analyzed with a spectrometer, a series of dark spectral absorption lines appear in the continuous spectrum. The dark lines indicate the frequencies that have been absorbed by the atoms of the gas. It has stimulated progress towards the modern quantum theory. In 1992, Bohr was awarded Nobel Prize in Physics. De Broglie explanation of Bohr's second postulate of quantization. Louis de Broglie urged that electron in its circular orbit, as proposed by Bohr, must be seen as a particle wave In analogy to wave traveling on a string particle, waves too can lead to standing waves. Under resonant conditions, we know that when a string is plucked, a vast number of wavelengths are excited. However, only those wavelengths survive which have nodes at the ends and form the standing wave in the string. It means that in a string, standing waves are formed when the total distance traveled by wave down the string and back is one wavelength, two wavelengths, or any integral number of wavelengths. Waves with other wavelengths interfere with themselves upon reflection, and their amplitudes quickly drop to zero. For an electron moving in the nth circular orbit of radius Rn, the total distance is the circumference of the orbit 2 pi Rn. Thus, 2 pi Rn बराबर n lambda. Figure 1 illustrates a standing particle on a circular orbit for n बराबर 4. It means 2 pi Rn बराबर 4 lambda, where lambda is the de Broglie wavelength of the electron moving in the nth orbit. We have lambda बराबर h by p, where p is the magnitude of the electron's momentum. If the speed of the electron is much less than the speed of the light, the momentum is mvn. Thus, lambda बराबर h बटा mvn. mvn. So we have 2 pi Rn बराबर h nh बटा mvn or mvn Rn बराबर nh बटा 2 pi. This is the quantum condition proposed by Bohr for the angular momentum of the electron. Thus, de Broglie hypothesis provided an explanation for the Bohr's second postulate for the quantization of angular momentum of the orbiting electron. The quantized electron orbits and energy states are due to the wave nature of the electron, and only resonant standing waves can persist. Bohr's model involving the classical trajectory picture, planet-like electrons orbiting the nucleus, correctly predicts the gross feature of the hydrogenic atoms in a particular frequency of the radiation emitted or selectively absorbed. This model, however, has many limitations. Some are: the Bohr model is applicable to hydrogenic atoms. It cannot be extended even to mere 2 electron atoms such as helium. The analysis of atoms with more than one electron was attempted on the lines of Bohr's model for hydrogenic atoms, but did not meet with any success. Difficulty lies in the fact that each electron interacts not only with the positively charged nucleus but also with all other electrons. The formulation of Bohr's model involves electrical force between positively charged nucleus and electron. It does not include the electrical forces between electrons, which necessarily appear in multi-electron atoms. While the Bohr's model correctly predicts the frequencies of light emitted by hydrogenic atoms, the model is unable to explain the relative intensity of the frequencies in the spectrum. In emission spectrum of hydrogen, some of the visible frequencies have weak intensity, others strong. 5. The experimental observations depict that some transitions are more favored than others. Bohr's model is unable to account for the intensity variations. So, we need a new and radical theory based on quantum mechanics for complex atoms to provide a complete picture of the atomic structure. Laser light. There are low power lens lasers with a power of 0.5 milliwatt called pencil lasers. In figure we have shown the light from bulb and the laser light. Laser light are in a straight drive, but light from bulb in a crowded bay. If there are n atoms in a source, each emitting light with intensity I, total intensity I So then total intensity produced by ordinary source is proportional to Ni, whereas in a laser source it is proportional to N square I, where N is a very, very large, is considered as the laser light.